We're going to go ahead and take a look at one final example. We're going to look at the function f of x equals x squared plus 1 divided by x. And again, we're going to look for the highest power of x, which is x squared, and we're going to divide every term by that. So we get x squared divided by x squared, 1 divided by x squared, and from our denominator x divided by x squared. And so again, we reduce each fraction. X squared over x squared is 1, plus 1 over x squared is just 1 over x squared. And x over x squared, the x's cancel out and leave you 1 over x. And so wherever there's an x remaining, those terms are going to go to 0. And so we're left with 1 plus 0 over 0, which is just 1 divided by 0, which we know to be undefined. And so if it's undefined, that means there's not a value. So we were trying to find a horizontal asymptote, so there are none. So we'd say there's none. So when you're trying to find horizontal asymptotes, there's none. So in this case, if we don't have a horizontal asymptote, we move on to finding the oblique asymptote. And the way you go about finding the oblique asymptote is by doing long division on your function. So x squared plus 1 divided by x. And so I'm going to go ahead and set up my division. And if I'm missing any powers of x, I'm going to put a placeholder, or 0 placeholder in. And so x is going to divide into x squared plus 0x plus 1. So x goes into x squared x times. That's our division step. Then we multiply x times x. And then we go to subtract. And we get 0x squared, or we could just say 0. And then we go to bring down our next term. So basically, we're taking x and dividing it into 0. Well, x doesn't go into 0, it goes in 0 times. And so 0 times x is just 0x, or just 0. And again, I'm just writing in the x. It's just to kind of keep our placeholders lined up. I don't need to. I could just write 0 here. And then I go to bring down. And I'm trying to divide x into 1, and it does not divide into that. So that is our remainder. And so normally you would take your remainder and you would divide it by your divisor, which is x in this case. And so we're left with the quotient x plus 0, and with the remainder 1 over x. Now, since we are talking about x going out to positive or negative infinity, because that's what happens when you're talking horizontal or oblique asymptotes, that means this fraction 1 over x, this remainder piece, and this will be the case every time, goes down to 0, because 1 divided by something really big goes to 0. And so you basically, in a sense, disregard the remainder piece. And so at the end of the day, we would say that our oblique asymptote is y equals, you don't need to write the 0, so it would just be y equals x. And that completes this third example on horizontal or oblique asymptotes.